Well, everyone, welcome back to my little heaven in the corner of the kitchen. This everything you see here is kind of a summary of part one that I did yesterday. This experiment was to figure out if, when doing a water circulator or a sous vide, if it were important to have an insulation device. So what turned me on to this was the guys over at Sous Vide Everything. They did a 24-hour Ossobuco the end of 2018, which I wanted to do something nice for New Year's Eve. So I borrowed that recipe, and it came out wonderful. You should definitely try that. Except one thing is that it was 175 degrees for 24 hours. And in my little corner of the kitchen, that was pretty warm. So I was thinking, well, hey, I wonder if I could do a insulation device and if it would even matter. So yesterday I posted I posted part one and kind of showed how I did it and what parts I used. I used the container from Omaha Meats from a Neighbor, cutting board, sous vide container, infrared device, and the Joule off Amazon, the pan I got from Sam's, and then the ThermoWorks remote thermometer I got, which if you don't have one, or if you're looking for one, it was great. It's got two probes. You could do a dome probe, a meat probe, two meat probes, two dome probes, or a dome probe and like a surface probe, however you want to do that. What's great about it is you can set minimum and maximums for protection. If you left the little piece on, the flow too much and it got over temp, or if the charcoal burned out and it went too low, you can adjust that for both probes. So you can check it for your meat. It'll tell you when it's done. You can get warned with your internal temperature if it got too high or too low. That way you're not wasting hundreds of dollars worth of meat. So part two is basically just to kind of tell you what I did. So in part one, I went ahead and set the water to 175 degrees for the container inside this device with the lid on and the Joule barely poking out, which I have to tell you that there wasn't a whole lot of condensation, which was surprising for me. And even when I did lift the lid on the insulation, there wasn't a whole lot of moisture, which was kind of cool, I thought. So the results were under the insulation, which I did yesterday. It took 1 hour to go from 58 degrees, which was what the starting temperature of the water was, to 175 degrees, which was our target. 1 hour. So got busy, lost track of time, and so it took me a little over an hour to get back to it. And what I did was, instead of turning the Joule off, I reduced it to its minimum temperature for circulation, which is 68 degrees Fahrenheit. So from 175 degrees to 140.8 degrees, which they say is where your danger zone is, right? Botulism and, sickness and diarrhea and all that stuff. So I started the trend down at 5:36 p.m. and it hit 140.8 degrees via the thermo smoke, thank God, because that told me while I was sleeping, ding, 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 hello. That way I didn't have to stay up all night, which is fantastic for long overnight smokes, so you don't have to tend to it all day long. It stopped, or it got to its lowest temperature that we wanted it, or I wanted it, at 3:38 a.m. So it's 10 hours, roughly 10 hours inside the insulation to go from 175 to danger zone. So this morning I woke up, I said, well, let's reverse that. Let's take away the insulation. Let's get some fresh water, which we made sure was at 58 degrees, and go ahead and start it. And we did at 10:27 this morning. And it took the same amount of time, 1 hour, plus or minus a couple minutes. You know how that goes. It's not really standardized. So 1 hour, it seems to be the exact same. So on startup, the water has the same amount of time to get to temperature. The really cool part is once I shut it down, it went from 175 degrees to 140.8 degrees in about an hour and 40 minutes, which is, at my calculations, an hour and 37 minutes. So big deal, right? If it's a long brisket or a piglet, or if it's a pulled pork of some sort, and maybe if you don't have a Joule, but maybe an ANOVA or something else, it malfunctions, or you lost electricity, or, who knows. So could potentially be kind of catastrophic if you couldn't get home in time, or something happened while you were at work and it was supposed to be for days and days and days, and you just kind of forgot about it in the corner of your kitchen or in your garage or whatever. Could be awful. But the coolest part about it is that this little image that you see here is kind of like my awful 3D design of the container. See the Joule at the top? It's great. So everything in black, the numbers, are the external temperatures I used with the infrared thermometer on the left side, the front, the right side, and then the top. And this is at hours and hours in, just to see kind of if, once the styrofoam heated up and it kind of heat soaked and everything was very similar to the same temperature. And I got 80s, 80, 85. The top, of course, heat rises, so that was pretty standard. But, 80, 81 degrees on the sides and the front. And so that was my first, last night we did that. And I was like, oh, that's great. There was almost no heat coming from this container. It was great. I can tell you from the ossobuco recipe, there was tons of heat. So this morning we did the same experiment that we had done with ossobuco. And those numbers are in purple. And now understand that it's a clear container and it's water, which is clear. And so infrared doesn't really do justice as far as the rebound, they say, where it can give you an accurate temperature reading. But it was hot. It was really hot. It was radiating heat, which is what I remember it doing last week for New Year's Eve. So if anything else, if you're doing a long cook with a really expensive piece of meat and you need to make sure it's taken care of, and maybe you're conscious about money, how much electricity it's going to take, or maybe you just don't want your Joule or your ANOVA to go all out for 4, 5, or 6 days, then obviously with the 70-degree heat retention, the difference between insulated and not, it probably is not going to work very hard. And with it being able to take 10 whole hours to come down from 175 to danger zone with nothing in it, which I mean no meat, there's no substance. So if you were to repeat this, which I could do in the future, that may be part 3 of this, where I get like a 60-hour brisket and I put it in there at 100 and whatever degrees, I have to do my research. And then just kind of do the same experiment with that and see how long it takes for an actually heat-soaked large piece of meat, and the water and the insulation all done and, heat-soaked, and see how long it takes for that to go to danger zone. I mean, it could be, what do you think, like 16 hours, 20 hours, maybe in a whole 24 hours, which would be kind of great just in case you wanted to go to work, pull the plug, on your app, and then eat it the next day, and you don't even have to take it out. You don't have to put it in the refrigerator. You don't have to wrap it up, and so it can stay in its nice little comfy container there. But yeah, I think that about did it for part 2, and I hope you enjoyed that. And if you've got parts and pieces laying around the house so you can get them cheap or free, then why not? Sounds like a cool thing, especially if it's going to be internal and you don't have to worry about, like basically a furnace radiating heat for 24 to 36 hours. Might not be a bad go. So anyway, hope you enjoyed. Take care.